All right, circle area part 3, going deeper with the area of a circle. Okay, the first one, the point 40 lies on a circle with the center at the origin. And what is the area of the circle? Okay, here's an example. So here's a circle, and one point lies on, let's see, let me make sure I got this. So this 40 is the point right there. That's the point 40. And the center is on the origin where it says the center. That's the origin. That is right here. And what's the area of the circle? Well, what we have is our formula. Area is pi times the radius squared. And the radius is 4. That's this distance from the center to the edge right there, 4. And times pi. So order of operation says you have to do the 4 to the second power first, and that is 4 times 4, 16 times pi. And this would be the exact answer. And usually we'd write the exact answer as 16 pi. But you're asked to round to the nearest hundredth right here. And when you have that, that usually means you're going to multiply by 3.14. And there it is, 50.24 square units. Oh, and, we're talking about square units. So the number of squares inside of this figure. Actually, that's kind of interesting because I could, so supposedly there are 50 a little bit more than 50 squares in here. Do you believe it? Try counting them. All right, but I'm going to move on. All right, a radio station broadcasts a signal over an area with a radius of 40 miles. The station can relay the signal and broadcast over an area of radius 65 miles. How much greater is the area of the region when the signal is relayed? Okay. Let's first consider the word relay right there. What does relay mean? Okay, I'm thinking like a relay race. Something gets passed off to the next person. Well, that's similar to what's happening here. You have this radio station. Ooh, here is the radio station. And it has the signal that it's broadcasting. It's that radio signal is going out to all the people with their radios and stuff. And it only goes so far. Maybe it goes out farther and farther, but then there's this relay tower over here. The relay tower, it will hit the relay tower and then it broadcasts it and makes that area go even farther. So it bounces it out. So the circle that it gets to cover is larger with that relay tower. So it hits the relay tower and then it bounces off and it gets projected out for more people. Okay, so enough of that. Trying to give you a visual of what relaying means. But let's get on to the problem. So the plan is we're going to calculate the area of the original signal and the relay signal and subtract the two areas. So the original signal is pi times the radius squared, and it starts with 40 miles, and 40 squared is 1600. So there's the area of the original signal. I'm just going to keep it like that. I'm not going to multiply it by pi yet. I'm going to keep it there. And the relay signal is this. It's going to be 65 squared, which is 65 times 65, which is 4,225 times pi. So I'm going to take the difference of the two relay signals, and I'm just going to leave pi out of it for now. Just for now, we're going to just hold off on that. And the difference will be 4,225 pi's minus 1,600 pi's, which is 2,625 pi's. Finally, I will multiply 2,625 times, so this will be 2,625 times 3.14, which is 8,243 square miles. That would be our final answer.